Hi again, Captain Peter Cutsey with part 2 of adverse weather operations, and this is cold operations. We're in Belgrade at the ramp. The temperature is minus 35 Celsius, the QNH 1000 hectopascals. Let's get right into the PowerPoint. This is a slide summary. We'll go to the main menu and we'll talk about de-icing, anti-icing. Before we get into the slide, remember that most airport authorities do not permit de-icing, anti-icing at the gate because of the contamination of the ramp areas. So follow the airport authorities' procedures and also your company SOPs. We're going to assume today in Belgrade that both the airport authorities and the company SOPs are such that we will push back to a dedicated area before commencing. Areas on the ramp are slippery or can be slippery, therefore good communication with the tractor driver and lead that you won't really start the engine number 2 till the tractor driver gains momentum. This will permit an easier pushback and won't cause slipping. Testing of undiluted de-icing, anti-icing fluids has shown that some of the fluids remain on the wing during takeoff, rotation, and initial climb. The residual fluid causes a temporary decrease in lift and increase in drag. However, the effects are temporary, so use the normal takeoff rotation rate. Caution: operate the APU during de-icing only if necessary. If the APU is running, ingestion of de-icing fluid causes objectionable fumes and odors to enter the airplane. Ingestion of snow, slush, ice, or de-icing, anti-icing fluid can cause damage to the APU. So don't run the APU unless you have no choice. If de-icing, anti-icing is needed, APU is needed, first officer's duty. The APU should be shut down unless APU operation is necessary. And then call flaps up. So really, you're at the gate. We'll assume that when it came to the engine start, the after start or the before taxi procedure, that you would not lower the flaps. So that's something that you want to discuss. And if you do lower the flap, you're going to have to call for flaps up. But really, if the ramp is contaminated, you wouldn't lower flaps, leave them alone. So make sure the flaps are up. This prevents ice and slush from accumulating in the flaps cavities during de-icing. So this is in the FCOM, but really in actual procedures, you wouldn't lower the flap. Thrust levers idle. Reduces the possibility of injury to personnel at inlet or exhaust areas. Now we're going to assume now that we've actually pushed back and the engines are started. Warning: ensure that the stabilizer trim wheel handles are stowed before using electric trim to avoid personal injury. Stabilizer trim units set. Set the takeoff trim. The captain does that. Both pilots will verify that the trim is in the green band. Engine bleed air switches off. First officer will do that. It reduces the possibility of fumes entering the air conditioning system. APU bleed switch off. It reduces the possibility of fumes by entering the air conditioning system. Now, after de-icing, anti-icing is complete, let's just talk about what we're going to do in the de-icing. Normally, there are two applications, a de-icing application and an anti-icing application. The holdover times, which you would have checked with maintenance and your engineering and both crew members would have all agreed on what holdover time was used. I won't get into that It is something that's separate and not complicated, but it takes a lot of time to ensure that you go to the right charts. They're all in the performance part of your manuals. So make sure that you go into them using the correct temperature and all the conditions. And of course, you will have discussed with maintenance or the spray lead what type of de-icing fluid you're going to use. For our example today and what we're going to do, we're going to be using either type 2 or type 4 fluids. So remember that the holdover time is started at the beginning of the second application. That's when both pilots would punch their clocks. You've got to be airborne before the holdover time expires. Otherwise, you need to repeat the de-icing, anti-icing procedures. So that's important. Get into the performance, and you would have taken this in ground school, but the point I want to highlight here is that your holdover times don't begin until the beginning of the second application. All right. Now, after de-icing, and anti-icing is completed, APU as needed. Caution, after de-icing, use the APU bleed air during takeoff can cause smoke in the airplane because of all the fluids that may have been ingested. So that's a caution. And if you do have to use it, you would want to make a PA to the cabin attendants and also to the your passengers that you may smell something and it's not irregular. It's just part of the de-icing process, something to that effect. So APU bleed air switch as needed. First officer, wait approximately 1 minute after de-icing is completed to turn the engine bleed switches on to ensure all de-icing fluid has been cleared from the engines. This is important. Engine bleed switches on. Flight controls check as needed, and the captain does that check. An increase in control forces can be expected at low temperatures. All right, so we're ready to taxi. We have a before taxi procedure and do the normal before taxi procedure with the following modifications. Generator 1 and 2 switches on, first officer, of course. Normally the IDG stabilized within 1 minute. Although due to cold oil, up to 5 minutes can be needed to produce steady power. If there is snow or ice accumulation on the wing, consider delaying the flight control check till after de-icing, anti-icing is accomplished. And I would personally suggest that. Flight controls check. The captain does that. An increase in control forces can be expected at low temperatures. Well, today the airplane, the outside air temperature is -35, and the airplane's been sitting overnight, so you can expect that for sure. Caution. The flap position indicator and leading edge devices annunciator should be closely observed for positive movement. If the flap should stop, the flap lever should be placed immediately in the same position as indicated. Flaps, check, first officer. Move the flaps up to flaps 40, or to move the flaps from flaps up, I should say, to flaps 40, and back to flaps up, i.e. full travel to ensure freedom of movement. Let's just go into the airplane, and we've got clearance to do this right now. So let's just go ahead and we'll time this function, and let's go through and start our timer here. Just bear with me. And we're going to extend the flaps through to flaps 40. And we'll just see how long it actually takes. through to flaps 40, and also on how long it takes to raise them, just to give us a good idea of what we can expect time-wise. This is also something to salt away in the event of an evacuation. Remember, in an evacuation procedure, which is a red item, you want to be able to actually select the flaps 40 as quickly as possible in the procedure. There we are at 42 seconds. So this is a simulator, but it may be very close, and it looks very close to me. Now let's go ahead and raise the flaps and see how long it takes to actually raise them to full up position. So you want to build this time in and take your time in procedures, because holdover time is what you're running the clock against. So you've got to plan, your time management's got to be perfect in order to get to the takeoff position, and knowing that you're going to expect takeoff at a certain time in order to make good the holdover time. So that is important. So we're still in the motion at 42 seconds, at 43 seconds. So that's something you can salt away. The gives you a good idea of the time-wise. If the taxi route is through ice, snow, slush, or standing water in low temperatures, or if precipitation is falling, taxi out with flaps up. And you'll find that's a good airmanship procedure. It will definitely be in your standard operating procedures. Taxiing with the flaps extended subjects the flaps and flap drives to contamination. And remember that. Leading edge devices are also susceptible to slush accumulations. Call flaps as needed, Captain. So flaps up before you start your taxi. Flap lever set as required. So we're going to say, for our situation today, we're going to use flaps up. Taxiing out to the runway. Caution. Taxi at reduced speeds. Use smaller nose wheel, steering wheel, and rudder inputs, and apply minimum thrust smoothly. Differential thrust may be used to maintain the airplane momentum during turns. At all other times, apply thrust evenly. Taxiing on slippery taxiways or runways at excessive speed or with high crosswinds may start a skid. When operating the engines over significant amounts of standing de-icing or anti-icing fluid, limit thrust to the minimum required. Excessive ingestion of de-icing or anti-icing fluid can cause the fluid to build up on the engine compressor blades, resulting in compressor stalls and engine surges. When anti-ice is required, an outside air temperature is 3 degrees Celsius or below, do an engine run-up as needed to minimize ice buildup. Use the following procedure. Check the area behind the aircraft is clear. Ideally, you want to do the engine run-up in position on the runway, and it can be part of a briefing that you would have given to your in-charge flight attendant and also a PA to the captain, not to cause anxiety once you get into the takeoff position. The takeoff position is the best. It'll give you an idea how slippery the runway is, and depending on traffic, it's ideal that you would make that request. If you can't do it because of traffic, then do it at the holding point, but make sure nobody is behind you. Very important. So a run up to a minimum of 70% N1 for approximately 30 seconds. And the captain does this, of course. And repeat as needed at intervals of 30 minutes. So if you're in an airport such as Chicago O'Hare, and there may be 50 airplanes taxiing out, you may have to, you may be on the ground having to run up, providing your holdover time hasn't been exceeded, you may have to run up twice. So you have to plan this thoroughly before you repeat your run up, especially as far as who's behind you. If you run up and there's somebody behind you, you're going to really damage their operation and give them the problems you're trying to avoid. If airport surface conditions and concentration of aircraft, that's what I just talked about, do not allow the engine thrust level to be increased to 70% N1, then set a thrust level as high as practical. And at a time, that's practical, at a thrust level, which is at that thrust level, whatever it happens to be. It may be something less than 70%, but you may not have any choice. Note, when operating in conditions of freezing rain, freezing drizzle, freezing fog, or heavy snow, run-ups to a minimum of 70% N1 for approximately 1 second at intervals no greater than 10 minutes. Enhance ice shedding. So you have to plan all of this before you get going. All right, before takeoff procedure, do the normal before takeoff procedure with the following modifications. Call for flaps as needed for takeoff. The captain does that, and flap levers set takeoff flaps as needed. So you remember you taxied out with flaps up, so you have to make sure that you actually select your flaps. Okay, extend the flaps to the takeoff setting at this time if they have been held because of slush, standing water, or icing conditions, or because of exterior de-icing or anti-icing. Verify that the leading edge flap extend green light is illuminated. Takeoff procedure. Do the normal takeoff procedure with the following modification. When the engine anti-ice is required and the outside air temperature is 3 degrees or below, the takeoff must be preceded by a static engine run-up. Use the following procedure, run up to a minimum of 70% N1 and confirm stable engine operation before the start of takeoff roll. A 30-second run-up is highly recommended whenever possible. Now, this is something you could discuss with the tower controller that you would like clearance to position. You'd like to do a run-up prior to the takeoff roll. If you're cleared to do that, that is the best position to actually do it. No one's behind you, and once you do run up to 70% N1 and static for 30 seconds, you can initiate the takeoff roll from that point, and that can be part of your briefing. You can select TOGA. The engines are stable, and of course, the EGT has rolled back. There's no point in bringing the thrust levers back and then going to 40% N1 for 2 seconds and starting all over again. It would make sense and good airmanship to actually depress TOGA from that point. That has to be part of the briefing. All right. So this concludes part 2 of adverse weather, cold weather operation. See you in part 3.